Hello everybody and welcome back. In this video, we're going to be transitioning to a new branch of psychology called developmental psychology. It's not very distant from what we were focusing on in our past class when we talked about cognitive psychology, and in particular, intelligence and differences in mental capacities. But what we're going to be doing today when looking at developmental psychology is examining how researchers sort of spun off the ideas of intellectual abilities that differ not only from person to person, but from year to year as we age, into a new branch of psychology that later bloomed into exploring a lot more than just cognitive capacity. But for this class and this specific lecture, we're going to start where developmental psychology all began, with the work of a very famous historical person in psychology named Jean Piaget. To understand developmental psychology, we oftentimes in an intro class do have to first spend some time talking about the intelligence material that we discussed in our last class. If you recall back to that discussion, we covered this kind of era of research in psychology where people tried to understand intellectual differences from one person to another by primarily focusing their attention on young children, ones who theoretically varied in their ability to solve a variety of different problems and all progressed in their kind of ability to solve problems as they aged, and this was used in an attempt to not only understand intelligence of young kids, but also eventually understand intelligence in adolescents and young adults. All of this work of Alfred Binet operated under the premise that as we aged, we just got better at answering lots of cognitive questions. We learned more answers, we acquired more information, and in doing so, revealed higher levels of cognitive performance, which could be tied to just the natural progression of aging. Well, this assumption that we just learned more as we aged was something that bothered a number of intelligence researchers and those looking at cognitive capabilities. One particular individual, when looking at this work of Binet, that was especially bothered by it as he was trying to tinker with the test and find ways to revise them, was a gentleman named Jean Piaget. This Swiss psychologist in the early 1920s started to try to find ways to refine the work of Binet and look at how children started to gain their knowledge on specific topics that were a part of these intelligence tests. And what he continually ran into was this finding that when kids were getting answers wrong, many of the answers they were providing that were incorrect in these intelligence tests weren't just random bad responses. Instead, they were ones that sort of suggested that these young kids seemed to be seeing the world in a completely different way, seemed to be perceiving the questions in ways that older children weren't perceiving them as. And this led Piaget to the conclusion that as we age, we don't just accumulate more information, we also grow to see the world in different ways and learn big perspectives. He focused his attention on this adaptive process that he said we all went through, and it eventually led to him forming this concept of something that we nowadays call cognitive development. And to really set the path for how we could study cognitive development, Piaget started utilizing three probably very unwilling resources for a number of years. His three children, Laurent, Lucien, and Jacqueline. He would give them a series of different tests as they were aging, trying to see not only what they could and couldn't do, but kind of when they reached specific types of milestones and how their perceptions were changing as they were reaching these milestones. He definitely studied many more children than just his three, but his work with these young kids allowed him to set the framework for this new theory of cognitive development that Piaget has become synonymous with over the last couple decades. Well, actually, over the last century at this point in time. So, what was at the heart of this cognitive development theory that Piaget proposed? As I mentioned before, his focus was primarily on how children learned to adapt to their environment. They were able to sort of change their thinking, how things worked and how they should apply their knowledge to different situations as they progressed from infancy into early adulthood. Now, most of his research in his early years was focused on the assumption that we're all progressing in pretty similar ways. He contended even at the end of his career that unless there were some biological or environmental reasons for a child not to progress, most of us probably went through the same series of changes and adapted on the same topics in a very uniform way, all the way from the moment we were born until we became adults. And this, of course, led people to ask about how we did this. Well, this led Piaget to introduce some really critical terminology that's still with us today in not only cognitive development research, but a lot of other areas of psychology as well. What is this terminology that still sticks with us today? One of the terms that Piaget started to use a lot, even though I think other researchers had mentioned it before, is this concept of something called a schema. Piaget insisted that when kids are trying to understand the world around them, what they're really trying to do is develop these mental frameworks, these ideas, how different elements of the world exist for us. He said we have schemas for things like gravity, what makes a bird, and how to walk, and how to interact with people in specific situations. His insistence was that some of our schemas were relatively small and specific to a specific event, while others were really large. They involved our understanding of how big aspects of the world worked. His insistence was that when we look at cognitive development, even though each of us develops our own kind of mini schemas at the same time, these big schemas, these big mental frameworks for how big concepts around the world around us, or how the world around us works, are what we need to focus on in cognitive development research. And he suggested that when we are processing these big ideas, we're constantly fluctuating between two different states of mind as we perfect these schemas and improve upon them in different scenarios. The first state of mind we find ourselves in oftentimes after creating a schema is a state of mind called equilibrium. This is when the schema we've developed seems to be working, seems to be applying to what it is we're encountering in the world. But he insisted that since a lot of our early schemas are inherently imperfect, simply because it's almost impossible on our own to come up with perfect, fail-proof ones at young ages, eventually we're going to run into conflicting information, things that don't necessarily match up with the schemas that we've created. And he said at this point, we enter a state of mind called disequilibrium, where we've got a schema for something, but it doesn't seem to be working perfectly. There's some type of problem. And he said when we encounter this disequilibrium, we get uncomfortable. And we try to find ways to remove this discomfort. We try to find ways to return back to that state of mind called equilibrium. And he said to do this, we have two different things we could potentially do. We could engage in something called assimilation, where we find ways to match up this new information with our existing schema. Sometimes this involves just adding a little bit to the schema, or maybe just kind of sort of forgetting or overlooking things that don't quite match the schema that we have, so we can just get back to that equilibrium quickly. He contended that many times when we do hold schemas, the first couple instances where we find stuff that doesn't match, we engage in this assimilation because it allows us to return to equilibrium pretty quickly. But he insisted eventually, over time, as we keep engaging in this disequilibrium act, where we're finding situations that don't match up with the schema, we're eventually going to start accommodating. We're going to start altering our schemas, deleting things, changing things, kind of redefining things that we're using to understand the world. And in doing so, hopefully that alteration of the schema can bring us back to some type of harmony that, again, creates that equilibrium. He called this transition equilibration. And he suggested, again, that we're constantly going through this with not only little stuff in life, but also big things. Let's look at an example of how this might work. Let's pretend, hypothetically, that you're a 3-year-old child, and you're going over to a friend's house to play. As you're playing with this friend, this weird fuzzy thing comes bounding out and starts tackling you and trying to lick you and play with you. And because you're a curious 3-year-old and you're pretty interested in this thing, you ask your friend, "What is this?" And the friend tells you, "Oh, that's doggy." And you immediately decide you need to create a schema for what makes a doggy a doggy. Now, if we were in an in-person class, I'd survey the class to try to figure out what you would have used as a 3-year-old to define a dog. Students in this particular activity often focus on things like the hairiness of this animal, the floppy ears, the 4 legs, the tail, the tongue, all of the kind of cute little nuances to dogs or puppies that most people focus on when at least they're dog people. Let's say you do create this pretty elaborate schema of what makes a doggy. So the next time you go over to a different friend's house and something like this bounds out, you can call it doggy. And usually the people will say, "Yes, that is our doggy." And maybe they'll even give it a name, which allows you to add more wrinkles to your schema. But notice, you're not changing the schema. You're not deleting stuff in these situations where your schema seems to be working fairly well, even if you have to learn a couple things like doggies have different names and doggies can be different colors. But let's say you go over to another friend's house after you've created this schema, and this comes bounding out. You immediately see the fur, the 4 legs, the cute cuddliness, the teeth, and the tongue, and all those things that scream to you this is a doggy, so you say doggy. In this case, your friend or the family corrects you and says, "No, that's kitty." Well, theoretically, you could find ways to assimilate. You could keep the schema of what makes this also a doggy, but maybe start talking about how maybe they call their doggy kitty. And in doing so, you could quickly do away with that disequilibrium that you're experiencing, even if it doesn't really work perfectly well. But if you keep going over to different people's houses and these things keep bounding out and you keep getting corrected when you call them doggies, you might eventually say, it's time to probably accommodate. It's time to alter my schema as to what makes a doggy and what makes these things that everybody keeps calling kitties, kitties. You might focus on ear shape and the shape of the face and the differences in the paws. Lots of subtle things that we as adults kind of take for granted theoretically have to be learned for us to be able to differentiate between these two different things. But over time, as you accommodate and now create maybe 2 different schemas, one for what's a dog and one for what's a cat, you can probably successfully, the next time you see one of these things, identify one as one or the other. This puts you back in that state of mind called equilibrium. This is exactly what cognitive development was all about, according to Piaget. So as I mentioned before, most of Piaget's work focused on big concepts that we learned as we progressed from infancy into adulthood. And this was really at the heart of his eventual model that he came up with that explained his theory of cognitive development. In this model, he contended that we could, because most of us progressed in similar ways, define different stages of cognitive development that we were in at different ages. And we could not only do that, but we could pinpoint specific cognitive concepts that we were grappling with, trying to kind of master and come up with the best schema for within each of these different stages. He suggested that after studying numerous children, we all kind of had a collection of specific problems that we were grappling with until we reached a specific age point, and when we were done with that, we'd progress to the next stage of cognitive development. After defining this idea, he then went out and kind of created a map as to how we progressed from infancy into adulthood and kind of gave names to these specific stages and the information within them that we had to learn. So what were these specific stages that Piaget proposed? There were some revisions to these stages later in his career, but for the majority of Piaget's career, he operated under the assumption that the main stages that we went through operated in 4 different steps. He suggested that most infants, for about the first 2 years of their lives, were in something called the sensory motor stage. He then suggested that once we got through that stage, around 2 years of age, we'd move into something called the pre-operational stage. And that would last for 4 to 5 years before we moved into new cognitive challenges in something called the concrete operational stage. And that short-lived one would be somewhere between 3 to 4 years long before we moved into something called the formal operational stage. Piaget's insistence again was that even there might be subtle, small differences from child to child, and we were all essentially grappling with the same things at about the same age in each of these different stages, and it led us to seeing the world in very different ways from adults when we were in each of these different stages. To understand how this works and also some of the specific terms and concepts within each of these, I thought it'd be kind of worthwhile to focus in on each of these different stages and the major terms so we can understand Piaget's theory of cognitive development in a more complete way. So let's start with the sensory motor stage, which again was the very first stage of cognitive development proposed by Piaget. The name, the sensory motor stage, sort of gives away what he thought our main cognitive focus was at this point. In essence, being able to understand these sensory messages that were coming from our sensory organs and be able to perceive those things around us was the main cognitive focus. He said we spent most of our time really trying to master during these first 2 years of life. Once we, of course, were able to pick up on the environment, another thing that he said we had to really master was the ability to interact with said environment, to develop those motor skills that we sort of take for granted as children, adolescents, and adults. So he said most of our cognitive resources were just dedicated to that. And if we were in a developmental psych class, we'd even talk about different types of circular reflexes that he defined and how we kind of expanded our ability to not only make sense of the world around us at this stage, but how to react to those things that we were making sense of. But I want to focus our attention in this specific class, since this is just an intro class, on some broad picture ideas that he said we were also developing during the sensory motor stage. And those 2 broad picture ideas are something called object permanence and a sense of self. Now, object permanence, like many people argue, was one of the first ideas or concepts that Piaget put out there that really put his name on the kind of the list of famous psychologists. Object permanence was this idea that we had to understand that objects continue to exist and retain their properties even when we couldn't see them. His classic object permanence test is actually depicted here in the images you see to the left. You see on the top image a young boy who's shown some type of stuffed animal. It sort of looks like a blue monkey. The boy's looking at it, interested in it, and then the researcher, lab assistant, places a piece of paper between the boy and this monkey. If you look at this young child, he seemingly is indicating that he doesn't understand object permanence, by showing that he's no longer looking at this thing that he was very intrigued by, sort of suggesting that he doesn't really believe that object is continuing to exist. Now, if we were in an in-person class, I'd show you a video that highlights subsequent research that was done on this topic of object permanence and how children might actually understand this idea a little bit earlier than Piaget had proposed and might have nuances to it that don't quite fit this general scheme of just understanding that things continue to exist even if they're not being seen, versus they just suddenly magically understand everything exists even if we can't see or hear it. Another thing that was within this area of cognitive development was this thing called a sense of self. Again, if we were in class, it'd be a little bit easier to explore this, but just understand that a sense of self is this notion that we continue to exist in a world that's not just about us. Right? We are a part of the world. There's others around us that have their own perspectives, that see things, that kind of experience their own lives. He said that as children get into about a year and a half, not only are they developing this understanding of object permanence, but they're starting to develop this sense of self. And one of the classic tests he used to really show that kids could recognize themselves and kind of recognize that people could see them was this thing he called the ruse test, where he would put a red dot on the noses of children, stick a mirror in front of them, and see how they would react to this face with the red dot on the nose. He suggested that if children reached for the mirror, they didn't quite understand that they could present a reflection and that they were a part of the world around them. If they had this sense of self, they would theoretically reach for their own nose, kind of indicating that they recognized who they were and recognizing that they could see themselves in this world around them. Now, many have questioned whether or not this was the perfect test of a sense of self, and whether or not senses of self were more complex, much like issues with object permanence. But again, these concepts were a part of Piaget's sensory motor stage and really were big focuses of young children that Piaget tested and really seemed to kind of give us a sense of what we were mastering in the first 2 years of life. He insisted most of us got through these things, and eventually at age 2 moved on to a new stage of development and a new set of problems. Now, as was mentioned before, once kids leave the sensory motor stage, they theoretically advance to what's called the pre-operational stage. In this stage, Piaget argued that there's a lot of things that we're learning more on a conceptual level. We go beyond just trying to control our bodies and instead start to try to understand just the basic elements of how the world around us was working. One of the things that we have to develop, which is sort of tied to this sense of self that we talked about previously, is the ability to overcome this egocentric thinking that we've developed at a young age. Remember, we are theoretically trying to solve problems around us and make sense of the world, and he said one thing that inevitably comes for most children as we're learning about the world is this notion that not only does the world revolve around us and that really the world's just interacting with us, but we develop this notion that everything we know, everything we experience, is the same as what everybody else knows and what everybody else experiences. Piaget thought that around 3-4 years of age, kids start to grapple with this type of egocentric thinking. They start to recognize that others might know things they don't know, or that others might experience things that they're not experiencing, or even more oddly, that they might be experiencing things that others aren't experiencing at the same time. And he said for about a year or so, kids really start to work in their minds on how to be less egocentric in their thinking and sort of take perspectives of other people. One of the classic tests that Piaget and others have used to highlight how we overcome egocentric thinking is this thing called the models of mountains task that is actually depicted here in the bottom image. In this test, Piaget or some developmental researcher would sit a child down in front of a big giant diorama like you see. In seat, in this case, you see A. They'll have a perspective on 3 mountains that all have different things on top of them. And they'll ask the child if their friend sat down in, say, spot B or spot C or D, what would that friend see when they looked at the diorama? And they'd give them different pictures for the child to select, like the 4 you see on the right-hand side. And what Piaget contended, and other researchers have confirmed, is that when children do have this sort of egocentric thinking, they're going to guess every single time, regardless of which spot the child hypothetically is being placed in, that child is going to see the same thing they see. They'll point to photo 1. They'll say this is what the child will see because, well, that's what they see. But as they get a little bit older, as they progress, they start to recognize that that can't possibly be the case. They're not usually great at it, right? This process of accommodation does take time. So in the beginning, Piaget and others contended that we just sort of guess once we start recognizing that others see things differently from us. As we get better at this, as we start to work on perspective taking, recognizing what others inherently know and don't know, and sort of learn this discovery process that we're all going through, eventually we start to recognize the kind of picture that corresponds with the angle that the child would see. And we recognize that, we have to tell people about what we experience, not just assume they know exactly what we encountered at a specific time. But this takes time. It takes sometimes years for us to get through that egocentric thinking that we need to overcome during this pre-operational stage. We also need to perfect our ability to kind of engage in pretend play. Sarcasm, wit is something that's often lost on young children because they can't understand, oftentimes when they're around 2 or 3, that you might say something that's not true, or you might describe something in a way that's not accurate. As we get older, we start to recognize in 3, 4, 5 that we can pretend something's hot when it's actually cold, or we can, I don't know, hypothetically talk about something that might happen when it's not actually happening. That's what pretend play is all about, and you can actually see that depicted in the picture in the upper left-hand corner. We have a young girl who looks like she's around 3, maybe 3.5 years old, having tea with her sister that looks like she's about 1.5 years old. If you look closely at that picture, you'll see that the older sister seems to be understanding this idea of pretend play and seems to be enjoying it. She's got her finger daintily put into a teacup. She's very delicately holding her piece of cake that she has. I'm guessing she's probably said 100 times how fun it is and how delicious the tea is and how wonderful her cake tastes. But if you look at her sister, you can see the frustration on her face because she seems not to understand this pretend play. If you look at her cup, the younger sister's cup, you'll see it's all mangled with what looks like a bite mark on it, probably indicating that she's tried to drink this hypothetical tea over and over again and has gotten frustrated when she just doesn't seem to be getting this tea her sister's talking about. And if you look at the vice grip that she has on the cupcake that she's holding, you can probably guess that she's tried to take a bite of that cupcake a couple times and gotten really frustrated as to why it doesn't taste as good as her sister's cake. All of this is really highlighting how learning pretend play, learning to just kind of deal with the differences between reality and pretend, is something we have to develop. It's not something that just automatically is ingrained within us. And Piaget and other researchers in cognitive psych have confirmed that this is something that we're working on at a young age. They've also confirmed that one of the things that Piaget insisted we focused on most during this stage is a really critical thing. And it's learning to understand something called symbolism. That certain things can represent others through some type of symbolic meaning. This can be using scale models to represent other things, or using gestures to represent other stuff. But usually when we're talking about symbolism and the thing we focus on from around 2 to 5, it's learning vocabulary. It's learning words and how they work and how to describe things and how to talk about something. If you've ever been around a young child, you might understand why Piaget insisted that this was a main focus for most kids between the ages of 2 and 5. Because most kids between 2 and 5 are constantly talking and constantly asking the same question over and over again. Why? Why? Right? The why question might be different in different languages, but almost all children do this to sometimes an infuriating extent when most parents and caregivers are asked to talk about this obsessive question that many kids do ask. You might think that many of the kids doing this are doing it to frustrate their parents or their caregivers. But what most researchers have contended is that this is actually them developing their understanding of symbolism and developing their vocabulary skills. Because by asking why, you not only get to learn about how the world works around you, but you also usually get exposed to language. You get exposed to kind of elaborate responses that are given to any random question that we might ask. This is something that my own son is currently going through right now, and I do occasionally want to bop him on the head for constantly asking why. But there is that need to kind of take a step back and recognize how important those questions are in not only his growth and understanding of the world around him, but in his growth in vocabulary. So the words we use, have lots of meaning at this stage, and they eventually, once we master a lot of them, get us through the pre-operational stage into the next stage of cognitive development. Now, before we get to the concrete operational stage, the next stage in cognitive development that I just foreshadowed, I do want to take a stop at the same stop Piaget actually did when he was talking about the transition from the pre-operational stage to the concrete operational stage. It was growth in understanding on a very complex topic we call conservation. And this particular skill that kids were developing, he thought was really critical in our understanding of the dynamics of the world around us and being able to understand concepts like math and physics and biology. He contended that kids, before they were around 4 or 5 years of age, couldn't understand that things would continue to retain their properties unless something was taken away or kind of added to them. This led them to, unfortunately, sometimes concluding that things like height or size were inherently tied to quantity of specific things. One of the classic tests that he used to show that kids couldn't understand conservation at young ages was one that's depicted here that he often called the beakers test. In this test, he'd filled 2 beakers with an equal amount of liquid, put them in front of a child, and ask first which one has the more if they were the same. And he would inevitably find that young kids would be able to identify that since the beakers were the same height and same size, that the water within them was equal since they were at the same level. He would then flip one over, like you see in the picture depicted on the right, and ask them, now which one has more, or are they still the same? And what he would continually find is that kids who didn't understand conservation would inherently point to the one on the left, suggesting it was now somehow bigger, even though nothing had been added or taken away. He also would find this with just stretching out things. If you would ask children 2 rows of pennies that were equal in number, say 10, that were originally equal in size, he'd ask which one has more, or are they the same, and a child would inevitably say they're the same. But when he spread one out and asked that same question, even though both contained the same number of pennies, that stretching out of the pennies, or whatever, I guess, coins they were using in his research, since, again, he was a Swiss psychologist, that stretching out of the coins would be enough to convince a child that there was now suddenly magically more in that pile that had been stretched out. And as kids started to progress, in his mind, out of the pre-operational stage into the concrete operational stage, they started to understand this idea of conservation. He contended that a lot of this dealt with growths in not only thinking, but language skills. He talked about how many children, when they first started to tinker with this idea of conservation, would start to talk their ways through it. Oftentimes still arriving at the wrong conclusion, but sort of recognizing that there was some issue with their logic and their thinking. He said these conversations that they were having with themselves would start outward, then turn to whispers, or even just mouthing the conversations that they were having. And eventually they'd start to develop this inner dialogue that he thought was critical to the concrete operational stage, something we'll talk about next, that allowed them to understand conservation. Now, this transition is something that many cognitive psychologists still do focus on when talking about cognitive development. But it is important to note that much like his issues with timing when it came to things like object permanence or a sense of self, there seemed to be some timing issues that Piaget ran into when he was testing this concept of conservation. Most people now contend that most kids can understand the gist of conservation if the questions to them are worded correctly by around 4 or 5 years of age. In fact, they have a pretty darn good grasp of it by the time they're 6. And this definitely didn't necessarily align with the work that Piaget had done and the timing that he had come up with. Now, we're going to discuss this more a little bit later. But I want you to understand that this particular concept, the idea of conservation, still to this day is sort of perceived as the bridge between transitioning from a pre-operational type of thinking to what's now called a concrete operational thinking. But as was the case for pre-operational thinking, there's more to it than just learning about conservation. When kids get into the concrete operational stage, what they're developing for the very first time is sort of mental skills that are internalized. Before this point, Piaget and other cognitive developmental psychologists have argued that most of the child's learning is more external in nature. Right? They're verbalizing everything they're learning, and they're encountering stuff in an outward world. And as children start to get to about 6 or 7, they start to, for the very first time, develop this inner dialogue, be able to talk to themselves, to ponder about things, and to maybe even peer into their own mental world. This is sort of the indication that children are starting to develop a really critical skill that's essential to the concrete operational stage called metacognition. The ability to not only think about your thinking, but access things like how tired you are, how you're feeling about a specific thing, how you might want to think about something in a different way. And once you're able to engage in these metacognitive skills, well then you have the ability to start to develop other things. One thing you can do is increase your memory, which allows you to do and undo your things in your mind very easily. If you've ever been around a 5 or 6-year-old, you can understand how advancing to this stage is very valuable. My favorite example of this is when we talk about counting. In fact, I have an example right here on this slide that relates to it. I call it the penny example. So if I were to ask you to count how many pennies were there, just like any 4 or 5-year-old, you'd probably be able to count them very easily. In fact, we can do this. We count them. And then I were to say, take some pennies away, and ask you how many were there. Again, I'm guessing, much like a 5 or 6-year-old, you can tell me how many pennies are now there. Here comes the internal thing. If I were to ask you, and say a 5 or 6-year-old to close your eyes, and imagine me putting all the pennies back that I took away, and asked you how many you would see when you opened your eyes, you, even if you didn't peek, would probably know that there were going to be 10 pennies in front of you. But a 5-year-old, 6-year-old, because their metacognitive skills just aren't there, they're not able to retain stuff in their head as well, they would be lost on this question. They'd have no idea how to figure out how many pennies were up and how they would even go about figuring that answer out. This is something that takes time. But as metacognitive skills improve in this concrete operational stage, as other internal mechanisms start to get better, children become more complex in their thinking, and they're able for the very first time to not only play with memory and with language in more complex ways, but they're able to start to make connections between things and ideas that they couldn't before. One of the things this allows them to do for the very first time is to engage in analogy work. Something we might take for granted is actually something very challenging for a 6 or 7-year-old. A great example of this is the one you see pictured in the lower left-hand corner, or I guess the words in the lower left-hand corner. If I were to ask you, run is to walk as fast as to, you would immediately know the answer. For kids who weren't quite through this concrete operational stage, or maybe hadn't gotten there, this could present a very challenging problem. This could definitely result in a child being very frustrated, assuming that there is no right answer to this question. Once we get through this concrete operational stage, though, once these metacognitive skills have really bloomed, well, then that becomes an easy question, and children are ready to tackle more kind of conceptual, difficult ideas. And when they reach this point, they finally arrived at the last stage of cognitive development, the last kind of hurdle that kids need to overcome to think more like most adults, called the formal operational stage. In this formal operational stage, as I mentioned, growth in cognitive development is more on the abstract level. It's more on being able to talk about hypotheticals and deduce how things could potentially play out without any real path or script that you can go off of. For a while, this takes time. If you've ever been around an 11 or 12-year-old, you might have encountered situations where they imagine what it would be like to go on a trip or to do something in school. You might be a little baffled by some of the conclusions that they come to. But as we progress through this stage, we theoretically get better and better at hypothetical reasoning, at kind of deductive conclusions as to what's next and how things will come about. And it allows us to just process the world and understand the outcomes of our actions significantly better. But as we're developing these skills, not only are we often imperfect in our hypothetical thinking, but we can have some kind of unusual problems pop up. A researcher that built off of this theory of Piaget's, named David Elkin, actually introduced a term, a concept that stuck with us today, called adolescent egocentrism, to explain one of the side effects that happens at about this age. Elkin suggested that when we get to around 11 or 12 and we start thinking about all the hypothetical worlds around us and the thoughts that others are having, we come to this sort of egocentric mode of thinking again, where we don't necessarily assume that everybody knows what we know and everybody thinks what we think, but instead, now we think that everybody, well, just cares a lot about us. We have this perception that everything we do is under a microscope and everybody is overanalyzing every aspect of our lives. We also tend to, since we're getting into the hypothetical world, imagine scenarios that are going to play out for us regardless of what we do now. This relates to something that he called a personal fable. Personal fables on their own aren't necessarily bad, right? Imagining you're going to be a doctor someday or a pilot or whatever is perfectly fine. But Elkin contended that with this personal fable also came this perception that this was an inevitability, that, say, trying in school wasn't important just because, well, you were destined to become something. Or it was okay if you were going to do something risky because, well, you were obviously guaranteed to survive this because you had this future laid out in front of you. Now, Elkin, much like Piaget, contended by the time we got to about 14, 15, these things sort of went away. Our abstract reasoning got significantly better, and eventually we started to all think the same way, being able to deduce how things work and how the world around us is going to play out. But it's also important to note that, much like we talked about before, there were some skeptics on these conclusions, many that suggested that this timing didn't seem quite right. So, to understand the critique of Piaget that I've been alluding to a couple times, we want to just reiterate his main goal when trying to understand cognitive development. He was operating under the assumption that children all progress naturally through specific stages of cognitive growth in their attempts to just sort of understand the world around us. His big push was that unless there were biological or environmental factors really having a heavy weight in a child, all children would theoretically progress through these stages on their own without any hindrances and hit all the milestones that he laid out in his map over the years of his career. Now, even though we can definitely celebrate Piaget for his breakthrough recognition that children do see the world differently from adults, there are lots of problems that people have poked at with Piaget's theory. A large portion of them were primarily focused on his timing of a lot of milestones that he laid out. To be fair to Piaget, he was working from scratch. There was nothing else that he was building off of. This was his own idea, and he had to create his own tests to try to understand where a child was on different cognitive tasks. So when he maybe mistimed when a child learned conservation or object permanence, or maybe gave kids a little bit too much credit when it came to developing abstract thinking by around 15, we might say that it's somewhat forgivable that his timing was off, simply because, well, there was more time needed to perfect the measuring tools and to really assess where most children were. One thing that has kind of continually been an issue for Piaget's work is his assumption that this is just a natural process and there's nothing really to be done to speed up or slow down this natural process. Well, even at the time, there were numerous researchers citing differences from culture to culture in terms of when certain milestones were both cognitively and physically being met from one child to another. There's also lots of research highlighting how specific types of environments, training even, could really enhance a child's learning and progress them through a lot of the cognitive milestones that Piaget laid out much earlier than one would think. And this brings us to another thing that started to be explored when we started to use the term cognitive development in our research. To understand this thing we're exploring, we have to introduce ourselves to one last character for today. And this specific individual lived a much shorter but very important life in the development of, well, cognitive development. It was a gentleman named Lev Vygotsky. He was a Russian researcher also interested in cognitive changes that we underwent. But unlike Piaget, who was more focused on coming up with the terminology and the map to explain kind of where we went, Vygotsky was more interested in the journey itself and how we progressed from one spot to another. One of the terms that is inevitably tied to Vygotsky is this idea of something he called a zone of proximal development. And this term really gets at the heart of Vygotsky's concept of how a child developed cognitively through those schemas that Piaget had laid out before. In Vygotsky's concept, he suggested that many kids could potentially progress and learn a lot of the cognitive concepts that Piaget had laid out on their own, but in certain situations, kids could be accelerated through these concepts if they were tested, or I guess trained, when they were in these zones of proximal development, where they were sort of receptive to learning a cognitive concept. And how did we get these kids through these concepts when they'd reached these zones, these sort of readiness periods? Well, Vygotsky introduced another term to explain this that has also been inevitably tied to him and his work. It's this concept of something called scaffolding, where we can help somebody learn a concept or make sense of something by trying to not teach them something that they couldn't possibly understand on their own, but teaching them something that they could maybe understand on their own, but really could be helped by teaching them just a slight bit above what they were currently at. A great example of scaffolding is when children who have decent reading skills teach those that are just starting out. Not kids that completely understand reading teaching those that are just starting out, but ones that are just a little bit above. The notion is that maybe they could tap into some specific things that these younger kids that are just learning reading are struggling with at the moment. Now, numerous studies have shown the utility of this scaffolding process, and also Vygotsky's ideas of zones of proximal development seem to kind of pan out when we look at individual and cultural differences that pop up. If the situation's right and the incentives are there, kids do seem to be able to pick up on things a little bit earlier than they could if they were just left on their own. This brings us to another really interesting point before we close out. When people look at the work of Vygotsky and the contrasting work of Piaget, one of the questions they come up with was, well, which one of these persons is right? And this sort of misses the mark. One, I want to point out that Vygotsky wasn't necessarily somebody that was trying to counter the work of Piaget. He was simply trying to look at cognitive development from a different perspective. And even though Piaget definitely had some issues with things like timing and his approaches, his ideas really have stood the test of time. And a lot of the work that he did laid the groundwork for other subsequent research on not just cognitive development, but other types of development we undergo that relate to the mind and the human experience. And that's where we're going to be traveling in our next class. Now that we've covered these ideas of cognitive development and sort of rested on this notion that neither Piaget or Vygotsky need to be the ones that are heralded while the other one is kind of rejected, we can understand where we went from these two individuals. And to do that, we're going to spend some time defining what developmental psychology is all about and then look at some of the common assumptions and techniques used by today's developmental psychologist. Hopefully, after we're done, you'll have a much better grasp of what developmental psychology is and how it's its own unique branch of psychology, much like behaviorism or cognitive psychology or biological psychology, the other areas we've covered thus far. But for today, I'm going to bid you adieu. I hope all of you are still doing well. I wish you all the best. Well, I hope to see you soon. Take care.